identification, and then preparation of the problem understanding, and then preparing a project charter, right? And presenting it to the sponsor with the charter and SIPOC, and giving him enough confidence that you can handle the problem very nicely and then get it solved. But these tool QFD and Kano model are related to product development. Development, you underline the word development. Development is different from improvement. Yes or no? Development is different from improvement. So these tools are mainly, used for development related project. Like you develop a new product, or you develop or design a new die, or develop a new process. So those areas, definitely these tools can help a lot. That means these tools will find more application in DFSS project than DMAC project, designed for Six Sigma. So now we are going to focus our attention to the measure phase. Now tell me, having undergone several sessions, learning several tools in the measure phase, what is your understanding about the measure phase? What are we supposed to do in the measure phase?
Measuring baseline performance.
Yes, accurate
Very good.
measure baseline.
Fantastic. Accurate. I like the word accurate measurement of baseline. So Sai Kiran told measuring baseline, and Nitin told accurate measurement of the baseline. Which one we can take? Baseline we can take, or accurate measurement of baseline we can take?
Accurate measurement of baseline performance.
So very, very important. So where are we standing? We should have the clear picture of our current position, right? And we have a goal. We know the target. And now we should identify the correct position of our current level. So you will have a proper understanding of the gap. Yes or no? If you don't have accurate information of your position as of now, then your understanding on the gap will also be approximate. So measure phase serve the purpose of giving you a clarity, giving you an accurate measurement of the gap in the performance. You can use any metric that you want. Use the yield metric, or use the DPMO, use the CP and CPK, or use any other metric that is relevant. That metric is nothing but your project Y. That project Y you want to improve. So the accurate measurement of the baseline is the goal. Now tell me, what is accuracy?
How close to fact?
How close you are to the fact. Suppose imagine I study a survey to understand my customer's level of satisfaction. And the survey report comes on a 10-point scale. The customer satisfaction is 6.5. Now, do you think accuracy is important here? Yes or no?
Yes.
On a 10-point scale, the survey result says 6.5. And you doubt that accuracy of the finding. You think that customers should have given you 8 and above. But the scores have giving a different picture, 6.5. Now what could have gone wrong? What could have gone wrong? Maybe 6.5. If 6.5 is the actual customer satisfaction level, then either you have to accept it, or if you are doubtful, if your mind is not accepting that low rating, then what does it mean? You are now doubting on the measurement system. Yes or no?
Yes.
Yes, sir.
You're doubting on the measurement system. So you must now try to improve your measurement system. That is also part of your responsibility. Right? And measurement system means all the elements you have used to collect the data. What are the elements you have used to measure the customer satisfaction? You have appointed some people, isn't it? You have delegated the job to some people. They are known as appraisers. And you have used a survey questionnaire, yes or no? That survey questionnaire is also an element in the measurement system, right? And then the samples, your people who participated, their selection is also important, isn't it? If you make a wrong choice of the sample, then that can also, give you misleading information. So, and if other than the survey, and then the environment under which the survey is conducted, environment under which the time of survey is also important. Yes or no? If you are in a busy work and people are asking you to fill up, participate in a survey, how will you participate? Will you give accurate results, accurate opinion? No. You will simply put all the tick marks for all the questions and then put your signature. Or you straight away put your signature and give back the empty form, asking them, them to fill on their own. So these are all the ways by which, your data can become, biased. All these things can make your data biased. So there is a terminology now coming here, bias. We want our readings to be unbiased. Yes or no? We want our readings to be unbiased. If bias is zero, whatever you see in your data is nothing but the reality. If bias is zero, whatever you see in your reading is nothing but the reality. You are accurate now. So what is the mathematical condition for accurate situation? Bias equal to
0.
zero. That's all. Only in order to ensure bias, you do calibration, you train your people who collect the data, you give them right instruction. There are many things you do. All of these things, the motive is to make sure the bias is eliminated. Now, bias can originate. See, when you are conducting survey, what kind of data you are dealing with? Can somebody tell me? I am conducting a survey. What kind of data I am dealing with? Is it a continuous data or discrete data?
Continuous.
Discrete data.
Discrete data.
Discrete data. We also call discrete data as attribute data. When you are dealing with attribute data, you have to ensure the survey questions are appropriate, survey timing is appropriate, right? And the sample participants are appropriate. All of these things will reduce the bias. Am I right? But if your data type is continuous, let's say I want all of you to measure the room temperature and I give all of you a thermometer, right? Imagine the training is happening in a classroom mode. Training is happening in a 5-star hotel. All of us are inside the 5-star hotel in the same room. I give thermometer to each one of you and I want each one of you to measure the room temperature. Do you think you all will get me the same reading?
No.
There are different
Yes.
readings possible, isn't it?
If machine model
Though we
function,
are in the same room, within the room, there is a possibility that no temperature difference is possible, isn't it? Closer to the air conditioner, the temperature will be low. And in the corners, the temperature may be high. Yes or no?
Yes. Yes.
Now tell me, what measures will you take to make your readings accurate?
average,
Yeah, average. Just average of some readings, 3 or 4 readings. Now, how to take the 3 or 4 readings? Is it important? Is that important?
yes,
Yes.
at different
You should cover
locations.
whole the room.
I have to tell you, correctly how
Define the
to measure the
location.
temperature, isn't it? So during the measurement of temperature, can the AC be in on condition or off condition? That's important instruction, isn't it? And whether the AC, for how much time the AC was running, is it just switched on or is it switched on and then stabilized? How should we take the reading? Switched
Stabilizer
on and then
condition.
stabilized, isn't it? Then only they must make the readings. Otherwise, our readings can easily, catch bias and our readings will become useless. So we have to be very, very careful. And that is the set of instruction we give before to the data collectors is known as operational definition. Correct? The set of instruction we give to the appraisers, to the data collectors is known as operational definition. So if the operational definitions are not clear, understandable, then bias can populate. So ultimately, we want to minimize the bias. And now, in order to minimize the bias, you must have a clarity on first, the measurement error. The source of measurement error is, there are 2 sources. One is inconsistency One is inconsistency, another one is inaccuracy. One is inconsistency, another one is inaccuracy. So instead of teaching you theoretically, let me do something, in real time. So all of you, do you have a smartphone?
Yes, sir.
Please open the smartphone and there should be a stopwatch inside your smartphone. There should be a clock and there should be a stopwatch. All of you, please open the stopwatch. And now, if you are talking about accuracy, the least count is very, very important factor. The least count is very, very important factor. Can you please tell me what is the least count in your stopwatch? All of you, please first show your stopwatch and then, yes, stopwatch. And yes, I could see in Teen's stopwatch, it's showing 0, 0, 0, 0, 0, 0. Now, what is the least count? All of you, do you know the definition of least count?
Yes, sir. 1 millisecond. 1 millisecond.
No, that is not correct.
Start point.
0.00 seconds.
Oh,
The least
20
measurable
seconds.
unit, na?
20 seconds.
Hello?
Seconds.
Least
1
measurable
second.
value.
Least is 1 second.
Less than 1 second is also possible.
So 1 upon 100 second.
Now you are correct. 1/100th of a second. Why I rejected your previous answer? Milliseconds?
1/1000 that one.
1/1000th is the millisecond. So all of you having a proper understanding of what are you going to measure and what kind of instrument you are going to use, what kind of unit you are going to use for your measurement is very, very important. First of all, there has to be a common agreement. Yes or no? If Nitin Sharma thinks that as a millisecond and you thinks that as a second, do you think all of you will help me in getting the accurate data? I'll be in a big problem working with all of you. Yes or no? So there has to be a proper clarity. That's why operational definition is important. So 0.01 second. Can I say the least count is 0.01 second?
Yes, sir.
I can also call it as resolution. Resolution of the instrument. It is known as least count of the instrument, also called as resolution of the instrument. Okay?
Sir, how 1/100? How, sir? Actually, I could not get it.
1/100 is 0.01.
Why 1/100?
That's what you see your stopwatch.
Mm-hmm.
It can definitely read in terms of minutes.
Mm-hmm.
It can read in terms of seconds.
Mm-hmm.
It can also read in terms of 0.01 second. Can you see that? You show me your mobile phone on the screen. I told you, but you did not respond. You show me your mobile phone on the screen and then you run the stopwatch. Then you realize how it is running.
Sir, got it, sir.
Got it right? Very good.
20 seconds.
So first thing is, operational.
Communication.
So a conversation is happening, but the other person is not able to understand the right meaning, isn't it?
Yeah.
So your operational definition should serve the purpose of what it should clearly communicate the actions needed. Otherwise, what will happen? Your data will automatically accumulate the error. We should try to minimize that. Okay, that's one thing. And one more thing, even though you have the correct operational definition, you have the same instrument with everybody, you want to follow the same unit of measurement, still the readings, can be different. This is known as inconsistency. This is known as inconsistency. The error that is accumulating because of the inconsistency in your readings is known as precision error. Before measuring the bias, you all should measure the precision error. What is the error I am telling now? Before measuring bias, precision error. What is precision error? Error due to inconsistency. So let us See here in this exercise, we had multiple measurement system. Each one of you acted as a measurement system. There were 17 participants right now participated. So how many measurement system we had? 17 measurement system. All 17 measurement systems should have produced 17 readings. All 17 readings should have been same. But it was not same. The error is named as reproducibility error. All of you understand what is reproducibility error? The variation in the readings while using multiple measurement system while measuring the same characteristics. The same procedure is followed, same instrument is followed, same characteristics is measured, but still there is a difference in the readings. This is known as reproducibility error. Now I would like to reveal one fact. How many songs I played?
Two.
Now, if possible, all of you write down your 2 readings in your notebook. Your first reading as well as second reading. Please write your first reading as well as the second reading in your notebook. What was your first reading and what is your second reading? How many of you are able to see exactly same readings? Anybody got same readings both time?
No.
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 There is little difference between your first reading and second reading. Am I right?
Yeah.
Yes.
Yes.
This is known as repeatability error. The fact here is, though I played 2 songs, both of them I played for exactly 60.00 seconds. Even though you hear 2 different songs, the duration is same for both the songs. If the duration is same, your both readings should have been same. Is my expectation correct?
Yeah.
But the reality, there is a difference within your reading. The difference within your reading is known as repeatability error. All of you understand? Earlier, the comparison was between measurement system. Now the comparison is within the measurement system, but between your readings, your own readings. All of you are with me? So can one of you tell me what is reproducibility error?
When
What
same
is the reproducibility error?
characteristics, when same characteristics is measured by many persons, and when we have a difference in the reading, that is called reproducibility error.
Excellent answer. Excellent answer. Fantastic. Now, can one other participant explain in the same manner what is repeatability error?
So if one reading is taken by multiple reading is taken by one person and still there is error, then it is reproducibility.
Multiple readings of
Taken
the same characteristics.
Statistics.
Same part, same characteristics. Only thing is multiple reading. So, but multiple readings, don't match with each other. And now the error is known as repeatability error. Now, all of you know what is repeatability error. All of you know what is reproducibility error. Even though we had 17 people here, none of you are able to eliminate this repeatability error. And every time we do the exercise, we have seen the reproducibility error. Now for sure, we understand one thing. The repeatability error and reproducibility error cannot be eliminated, but definitely can be controlled. So how much is the error? If you want to measure, what we do is we quantify the repeatability error, we quantify the reproducibility error, and then add them together. We quantify the repeatability error, quantify the reproducibility error, and then add them together. The summation is known as precision error. The summation is known as precision error. Always the error should be compared against the working range. Always the error must be compared against the working range. What is working range? Normally working range is nothing but the tolerance provided by the customer. Am I right? If it is a product you are dealing with, customer provides the tolerance. So let's say customer gives you a tolerance. Let's say you are working on a project where the dimensions are important. The dimension of a product are important. 100 mm length is required. Customer has given you a tolerance of plus or minus 0.5. Now, what is your working range? Maximum is 100.5. Minimum is 99.5. If it is in millimeter, then what is the range of your reading? 1 millimeter only. Now the precision error should be less than 10% of the working range. Your working range is 1 millimeter. So 10% of the working range is 0.1 millimeter. All of it, do you understand? 0.1 millimeter. So whenever you are producing data with the error of more than 0.1 millimeter, your reading is considered, invalid. Unacceptable. Your reading is unacceptable. The measurement system is unacceptable whenever the precision error is more than 10%. All of you, do you understand what I'm speaking? You understood reproducibility error? You understood repeatability error? When I add them together, that is known as precision error. After calculating the precision error, I want you to compare against the working range, which is nothing but tolerance. That means precision divided by tolerance. If it is more than 10%, measurement system is unacceptable. Less than 10%, you have a very good measurement system. Okay. Now, before we go for lunch, just one more terminology I want you to become familiar. What is the original duration of the song I told you?
60 seconds.
60 minutes. 60 seconds.
50 seconds.
Now, I want all of you to calculate the average of your two readings. You took two readings, right? Please calculate the average. Have you calculated the average? Calculated?
Yes, sir.
Okay. Can one of you tell me how much is your average now?
59.03.
59.03. What are your individual readings? Come on, what are your individual readings? Anil. Original readings.
Just missed the number, sir.
I got
59.03 is your average. What are your two readings? Okay, so Ruchita has typed it. 59.23, 59.55. So Ruchita madam, what is your average now?
59.89.
59.89. And now 59.8.
No, sorry. 59.39.
Okay, 59.39. If you look at the individual readings, yours 59.23. 59.23 is far away from 60.
Yes.
But your average is 59.39.
39.
So 59.39 is little closer to 60 now. That is little closer to the true value. 59.239 is definitely better than 59.23. Yes or no?
Yes.
So that's why we go for the average. So we calculate average to minimize the bias in our reading.
Yes.
But since there are two readings, some amount of bias is eliminated because of the average. Agree? First part of the
Yes.
bias. Now use the average 59.23. Find out the difference between the average calculated, which is 59.23, and your true value is 60. Please calculate the difference, madam, now. 60.00 and 0.6.
And 59.39. So that is 0.61.
Very good. 59.39 and then 60.00. The difference is 0.61. The 0.61 is now the final bias.
Right.
This is known as bias. If you are okay with this bias, then if you are okay with the bias, then you can proceed. But if you think the bias is too much, maybe you can try to correct your measurement system. What kind of correction you can do? You can calibrate. You calibrate your equipment so that what will happen? The error can go down. But please note, calibration can definitely minimize the bias. But again, the repeatability component and reproducibility component can anyway will play.
Right.
You have to know that. So first you get an estimate of the repeatability error, reproducibility error, combine it, calculate the precision, compare the precision error against the tolerance, and check the percentage. That percentage is given a special name known as gauge R&R. If the gauge R&R is lesser than 10%, then you calculate the bias. And then what to do with the bias? You can still eliminate the bias by calibrating the measuring instrument. So what to do if the bias is unacceptable? What kind of actions we can do? And we'll discuss that probably after your lunch time, because it's 1:05 now. So I would like to stop here, and after lunch we will certainly discuss about further details about the gauge R&R and also the bias. I'll show how you can generate data. Yeah, surely how you can generate that data, and then how you can feed it in the Minitab, and how the gauge R&R report can be generated, bias can be calculated. All that we'll see after lunch. Shall we break here for lunch?
Yes, sir.
Yes.